All right, for our first lesson for Unit 7, we're going to talk about rational versus irrational and simplifying radicals. This is a really big unit, so it's a lot to take in. If you don't completely understand it by the end of the lesson, please don't panic. We're gonna do a lot of practice in class. So first, we're going to do the little boxes at the top, and we're going to talk about perfect squares. So 1 squared is the same thing as 1 times 1, which is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. 7 times 7 is 49. 8 times 8 is 64. 9 times 9 is 81. 10 times 10 is 100. 11 times 11 is 121. 12 times 12 is 144. 13 times 13 is 169. 14 times 14 is 196. And 15 times 15 is 225. These are ones that you are going to have to memorize. So, looking at number 1, when you have a square root, some of you I've heard call that like a check mark. That square root is saying the opposite of squaring. So up above, we squared all of those numbers. So now we're looking at the square root. So the square root of 81 is saying what times itself equals 81? Well, 9 does. Number 2, what times itself equals 25? 5. Number 3, what times itself equals 49? 7. Number 4, what times itself equals 225? 15. And number 5, what times itself equals 169? 13. This bottom row, you will notice, all has negatives, but the negatives are in different places. So up above, is it true, like for number 1, that if it was negative 9 squared, it would be negative 9 times a negative 9, which is positive 81. But the only way to get a negative number inside there is if we have a negative number times a positive number. So when you have a negative number on the inside of the square root sign or the radical, it can't be true because I can't do negative 9 times negative 9 or 9 times 9. It would have to be negative 9 times 9, and those are not the same thing. So there's no way you can answer number 6, which means there's no way you can answer number 8, and there's no way you can answer number 9. So what that means is that they are non-real numbers. So number 8 is a non-real number, and number 9 is a non-real number. The difference between 7 and 10 is that negative sign is on the outside. So all that means is your answer is going to end up negative no matter what. Since the negative sign is on the outside, the answer is negative no matter what. So it's negative 5 and negative 13. So we need to find some definitions of rational numbers and irrational numbers and some examples. So first, it's going to be easier to explain what an irrational number is. An irrational number is a number that, an easy way to explain it is a number that doesn't make sense. Meaning it cannot ever be a fraction. It can't ever be a whole number. So an example of an irrational number would be pi. Pi is a number that just keeps going and going and going. There is no pattern. It just doesn't make sense. The square root of 2 is an example of an irrational number because I can't find a number that multiplies by itself to equal 2. So any square root that isn't perfect. Remember that a perfect square or a perfect square root would be like the square root of 36, because 6 times 6 is 36. So now we're going to talk about rational numbers. So anything that can be a fraction. So obviously an example of that would be like 1/2. Another example would be a whole number, because a whole number can become 4/1, so it can be a fraction. Another example of that would be like -8. So all negative numbers can be rational. Other numbers that are an example of it would be when there's decimals, that they do keep going, but they have a pattern. So like 0.25, where the 25 repeats, or 0.3, where the 3 repeats, or 0.18989, and the 89 repeats. Those are examples of rational numbers. So now we're going to talk about rational or irrational. So number 11, 4. Well, that's rational because it's a whole number. Number 2, that's the letter N. Sorry, I have to apologize. That's actually supposed to be a pi, not a letter N. So obviously it's irrational because it just keeps going and going and going. Square root 25 is the same thing as 5, so it's rational. The square root of 11, is that a perfect square? Well, I can't find a number that multiplies by itself to get 11, so it's irrational. Number 15 is a fraction. Remember, it has to be a fraction in order to be rational. Same with 16. 17, notice how there's not a dot, dot, dot at the end, so it doesn't keep repeating, which makes it rational. Which, this is a very important point to make, 3.14 is not the same thing as pi. So anytime that you need to use pi, you're going to have to ask your teacher whether or not they want you to use the pi button on the calculator, or if they want you to use 3.14. 18 is rational. There are no decimals that keep repeating. And number 19, if I look at that, I have to see if there's a pattern. It goes 1, 0, 1, 1, 0, 1, 1, 1, 0, 1, 1, 1, 1, 0. There is a pattern, but is it the same pattern that's getting repeated? No, so it's irrational. So now that we've covered rational and irrational, and again, I don't expect you to have it memorized or be perfectly fluent in it. We're going to do a lot of practice on it. But we're also going to move on to simplifying radicals. So the first step to simplify radicals is to factor the number under the radical sign if possible, so that one of its factors is the largest possible perfect square. So let's look at 80. So what we're going to do is we're going to make a factor tree. Well, 80, I know that 2 and 40 can go into it. I know that 4 and 20 can go into it. I know that 10 and 8 can go into it. So what we're going to do is just pick one of those to start with. So if we do 10 and 8, well, I know that 10 is 2 and 5, and both of these are prime, so I can stop there. But I have the 8 still, so 2 and 4 is 2 and 2. So I know this isn't exactly what it's telling you to do for the rules, because we don't have all of our perfect squares figured out yet. Since you don't have your perfect squares memorized yet, and if you do, great, then you should be able to move right along, but most of you don't. So what we're going to do is we're going to take our square root sign, our radical, and we're going to put all of our prime numbers in order numerically. So I have 1, 2, 3, 4 2s, and a 5. So what we can do now is we can take out any doubles. So this 2 can come out of the square root. This 2 can come out of the square root. And we are left with the square root of 5. So now we can multiply the 2's on the outside to become 4 square root of 5. If you were going to follow the directions up above, you would see that the square root of 80 is the same thing as square root of 16 times square root of 5. But again, you don't have your perfect squares memorized, and then the square root of 16 is 4, and we still have square root of 5 left. So this is how the rules explain you to do it, but until you get there, I want you to do it this way. So you're going to make the factor trees, put everything in numerical order, and take out doubles. So let's look at number 20. Square root of 200. Well, 200 is 2 and 100. 100 is 2 and 50. 50 is 2 and 25. 25 is 5 and 5. So I have 1, 2, 3, 4, 5 prime numbers I'm working with. So 2 times 2 times 2 times 5 times 5. All right, so I can take out a 2, and I can take out a 5, and I have a 2 left over, so it becomes 10 square root 2. You could have seen that 100 right here is a perfect square, so automatically you have square root of 100 and square root 2, so 10 square root 2. All right, 32 is 2 and 16. 16 is 2 and 8, 2 and 4, 2 and 2. So I have 1, 2, 3, 4, 5 2s. 1, 2, 3, 4, 5 2s. 2 2s can come out. We have a square root 2 left over, so 4 square root 2 is our simplified radical. Again, feel free to practice these on your own so you can pause and then check to see if you're doing them right. All right, 17. 17 is a prime number, so square root 17 is as far as it can go. If you look at number 20, you'll see that that is a perfect square. So 9 times 9 is 81, so that's as far as it can go. Then we have 52. So this is 2 and 26. 26 is 2 and 13. So we have 2 times 2 times 13, because we have a 2, and a 13. So a 2 can come out, square root of 13 is left, and this is your simplified radical. Last one. You'll see we have a 5 on the outside. We will deal with that 5 later. But first we need to simplify the 24. So 2 and 12, 2 and 6, 2 and 3. So what we're going to do is we're going to write our square root, but we're going to bring that 5 down first on the outside. Because what that is it's 5 times square root 24. So now we have 5 times 2 times 2 times 2 times 3. And a 2 comes out. So now we have 5 times 2 on the outside and 2 times 3 on the inside. So it's 10 square root 6. Finally, 26. We need to first break down this square root of 20. We still have the 2 that we're going to divide by at the end. So square root of 20 is 2 and 10. 10 is 2 and 5. So we have 2, 2, and 5. So I have square root of 2 times 5, but don't forget we're going to divide everything by 2 at the end. So a 2 comes out. I have square root 5, and I have divided by 2. Here's where you're going to have to start paying some attention. You see that you have 2 times 5, and then you're dividing by 2. Those really just cancel each other out. So square root of 5 is your answer. 27 is going to be slightly different and 28 because we have variables we're dealing with now. So first we're going to break down the 27. 27 is 3 times 9. 9 is 3 times 3. Then we now have 3, 3, and 3. So it's square root of 3 times 3 times 3. But don't forget we have our x to the third. So we're going to break that up. So we have 3 x's. And you're going to treat those the same way you've been doing. So a 3 can come out, and an x can come out, and we're left with a 3 and an x. So 3x times square root 3x is your answer. Now our last one, 44 is 4 and 11. 4 is 2 and 2. So we have 2, 2, and 11. So it becomes square root of 2 times 11. And then we have 5 u's. So 1, 2, 3, 4, 5. And let's take out doubles. I have a 2. I have a u. and another u, and we have 11u left over. We need to combine the two u's on the outside, so it becomes 2u squared, square root of 11u.